Well, we're gonna do a small review for chapter 2. So here I have this system from the book. The book is asking us to do is get the free body diagram and get the equations for it. So to work this out, we'll see that we'll do two free body diagrams, one for each mass. So I have mass 1 here, and I look at the mass and how many forces do I have. So you have A of t going to the right, that's the easy one. And then here, K2 is going to oppose to that movement. So this one I'm going to get it to the left, and this force is going to be equal to K2. And I look at my reference, X2 is the same reference as X1, and they're fixed reference. So the elongation of this guy, the total is going to be X2 minus X1. Okay, and then in the left hand side of mass 1, I have a force going to the left, it's opposing the movement, and this one is equal to K1 X1. And then I have the viscous one, so this is going to oppose as well, so this is going to be B1 B1. And also don't forget the inertial force, so this one is going to be M1 X1 double dot. Okay, so I have 5 forces total acting in mass 1. For the second one, I'll have a force applied through K2 that's going to try to push M2 to the right. So this one here is going to be equal to K2 X2 minus X1. You look, it's the same force that the one we draw for M1, but it has the opposite direction. Okay, and then V2, the one right here, is going to oppose that movement. So here we have V2 times V2, and also we have the inertial force. It's going to oppose also the movement. So this one is going to be M2 X2 double dot. So I have 3 forces in M2, 2 going to the left, 1 going to the right. So that's it for the free body diagram. Now I need to get equations for these guys. So what I like to do is keep my higher order differential positive in the left hand side. So what I'm going to do, I'm going to get all the forces going to the left as positive, and I'm going to equate them to the ones going to the right. So in this case, I'll have M1 X1 2 dot plus V1 V1 plus K1 X1 plus K2 X2 minus X1 equals to FA of t. Okay, so I have all the forces going to the left equal the forces going to the right. Or if you have the FA in the left hand side, that will be equal to 0, which is Dallenberg's law. So for M2, I'm going to do the same thing. I like to keep the coefficient with the highest differential positive. So I'm going to get M2 X2 double dot positive, and then I have V2 going to the left, so that's going to be also positive. And then I want to have a minus because this force right here is going to the right, is different direction as this guy here, so I'm going to have a minus here, so this is going to be a minus K2 X2 minus X1, that's equal to 0. Okay, so here in this example we already have our free body diagram for the 2 masses and the 2 equations, and this problem is all it asks us to do. So that's it for this problem.